Okay, so we've got iron as one of our elements that we're pulling off of this label. What else?
Sodium.
Sodium. Okay, let's do one at a time. Sodium. Aluminum. Boom, right there.
Carbon.
Carbon. I love it.
Vitamin
Right
A. Come on, boy.
Vitamin A is not an element. Calcium.
What does the A stand for? Vitamin A.
Phosphorus.
Does not think.
Where's phosphorus? Right here. Okay. Anything else? Okay, hydrogen from hydrochloride. Probably chlorine. Okay, we could get oxygen from water. We could get hydrogen from water. Okay, oh, excellent. We could get sodium from the salt. Okay, we could get carbon, hydrogen, and oxygen from the sugar. All right, listen up. Okay, so we are starting a new unit that's about how chemicals get named and also how we can figure out the formula of a chemical based on its name. So you're going to start looking at things that are like this kind of in a different way, because now on you're going to be able to tell exactly what elements are in the foods that you eat, even if they have a really freaky name, like sodium thiosulfate or something like that. Hopefully that wouldn't be in any of your food. Okay. That's what the name is called. Very cool stuff. All right, so moving forward. Okay. All right, so let's go back to page 1. All right. These new notes that you have here, these are called Cornell notes. You've probably seen them before. Right? So, page 1. The bulk of your notes, okay, the bulk of your notes is on the left side here. And over on the right side. Over on the left side in the column, there's like little questions as you go along, okay? These are what you essentially need to study, okay? If you can answer these questions based on the information that's right here, then you're doing good, okay? If you're not sure how to do it, you need to go back through the notes or come and ask me in order to answer these questions over here. Now, there's kind of a bummer because some of the whole punching holes went right through some of the questions. So if you have a question about what the question is actually asking, just holler at me, or you can get on your Fusion page and the paper without the holes is on there, so you can see the answer. Okay? So if I don't ask you to do any of the reading or anything like that. But if you wanted to get on your online textbook and follow along with what we're learning, this stuff is in chapters 7 and 6 of your online textbook. Okay, so alright. So the first part of your notes, okay, we're going to start out learning about molecules. Okay? So that's the word that goes in that very first blank. And a molecule is the smallest electrically neutral unit of a substance that still has the properties of that substance. Okay? So for example, if we looked at the element, at the molecule of water, H2O, okay, that's a molecule, and this molecule has 1 oxygen and 2 hydrogens attached to it. Okay? So this is the smallest possible thing that could be water. If we change this in any way, shape, or form, like if we remove one of the hydrogens, it's no longer water.
What is it then?
It's hydroxide, which is much different than water. Okay? So a molecule is the smallest possible thing that still represents all the properties of that substance. Okay, so 1 water molecule. And this water molecule behaves as a unit. Okay? So this thing acts as a 1, right? When it reacts with something, it reacts as H2O. Not just the O or not just the H. It reacts as a whole entire unit. It's like if you have a really best buddy that you never go anywhere without, okay? Then you guys are kind of stuck together. Don't do anything with it. So, some examples of molecules that you should write on your paper RCH4,
What's that?
methane. Okay. Also, this is H2O.
The stuff that's water and stuff. Really?
Another molecule is O2. Another one is CO2. And one more example is O3. Ozone. Alright, so there's a couple different ways that elements can bond together. They can bond together by sharing electrons, and that's what molecules do. They share electrons. They can also bond together by exchanging electrons, so either gaining electrons or donating electrons. But the way that we tell these things apart, how these things bond, it all goes back to the kind of element that's in the compound. Okay? So let's look at the elements here and decide whether they're metals, nonmetals, or metalloids. So we have carbon, hydrogen, and oxygen in all three of these elements. Okay? Okay, yeah. I need you guys to sit there. Alright, so
What?
okay, so back to this. What kind of elements are carbon, hydrogen, and oxygen? Are they metals, nonmetals, or metalloids?
Non-metals.
They're nonmetals. Molecules, okay, are always between nonmetals. You will never see a metal in a molecule.
Why not?
Because if it has a metal, then it bonds differently, and it's called something else. Okay, it's called an ionic bond. Alright? So, that's important to know. That's important to be able to differentiate. Okay? A molecular compound, this is also called a covalent compound. So on your notes where it says AKA, write covalent in there. Covalent, co means sharing, valence, sharing electrons. Okay? Sharing valence electrons. So a molecular compound is usually composed of two or more molecules. A molecular compound have relatively low melting and boiling points. Okay? And they're usually made up of nonmetals. So sugar is an example of a molecular compound. Let's see. Sugar is made up of carbon, hydrogen, and oxygen, all elements that are nonmetals. What happens if you put a bunch of raw sugar in a pan and you heat it up on the stove? First it melts and it smells delicious. And then what happens if you don't take it off the stove?
Burns. It smells bad.
It burns up and starts to smoke, sets off the fire alarm, and then everybody wonders why you can't cook and your house smells horrible.
How was your Thanksgiving meal?
So the reason why sugar does that is because carbon, hydrogen, and oxygen are molecularly bonded. They have low melting points. Okay? Have you ever done the same thing with salt?
No.
If you just put salt crystals in a pan and you heat them up, they will not do the same thing that sugar does. They'll just sit there. And unless you can get them to like 3,000 degrees, they will just continue to sit there. They won't do anything.
Does it get hot?
Why does salt not do what sugar does?
Because it's not the same thing.
It's not the same thing, but what? What is salt made of? What two elements?
Sodium and chlorine.
Sodium and chlorine. What kind of element is sodium?
Non-metal.
It's a metal. Metals have high melting and boiling points. That's why we use metals to make things that we don't want to melt, like your car, okay? You can't have a car made out of chocolate in Texas because what would happen
It
to
would
it?
melt and you wouldn't be able to go anywhere.
Yes,
People would
so
eat it.
while delicious, it would be pretty useless, okay? So yeah, we use metals for things that
You
we
have
don't
round bridges.
want.
Really?
Okay. Alright, so,
Can't they learn things?
okay. So what we're doing here is we're going to figure out which of these compounds is molecularly bonded or covalent and which is ionic. Remember, molecular bonds do not have any metals at all. Ionic will have at least one metal.
First one's ionic.
How do you know that, Bryce?
Sodium's a metal.
Oh, good job. Yeah, if there's one metal there, it doesn't matter. It's ionic. Okay, it can't be molecular. What about that next one? What are those two elements? Are they metals or are they non-metals?
Non-metal.
So that means that they are molecular or covalent. You can use one or the other, or you can use both. Covalent. Okay? Either is just dandy with me. What about that next one? What do we have? What kind of element is calcium?
Molecular. Wait, no. The thing is molecular.
Where's calcium on our periodic table?
It's a metal.
It's a metal. Somebody transition that. Wait. It's a metal. So if it's let's regroup and look at our big periodic table. Okay, see the green stairs?
It's both metals. Yeah.
Everything to the left of the green stairs are metals, with the exception of hydrogen.
Oh wait, I'm blind.
Okay, everything to the right in pink, those are the non-metals. Okay, the green are the metalloids. Okay, it's really important to know to be able to differentiate these for the rest of the year. Zach, I need you to pay attention. Okay. All right. So since calcium is a metal, what kind of bond is this?
Ionic.
It's ionic. It's ionic. All right. What about these next two?
They're both non-metals with covalent.
You nailed it. This is molecular or covalent. What's the name?
Ionic.
Why is the next one ionic? It's got aluminum. I know that mine is different than yours on your paper, but they both have aluminum, so they're both ionic.
Question.
Sir?
Is this still a compound if there's only one element?
No. Unless it's like O2, that means there are two oxygens, then it's a compound.
What is this one the fourth?
Okay, CF4. What do we got going on there? Carbon and fluorine, so how are those classified? Are they metals or are they non-metals? They're non-metals, so molecular covalent. Good. And what about that very last one, Yash?
Covalent.
You got it. It's oxygen, 3 oxygens, and oxygen is a non-metal, so that's a molecular or covalent bond. What?
Where can I find this? Like, since you're recording it, where can I find it?
On my fusion page? Okay. All right, questions on those? Got to be able to figure out what kind of elements are there in order to differentiate. Okay, so the next thing on your notes says diatomic molecules. You have to write in diatomic on the line. And diatomic molecules contain 2 atoms, but they have to be twins. Okay, 2 atoms of the same element. Okay, so like OH would not be a diatomic molecule because oxygen and hydrogen aren't the same element. But O2 is diatomic, and so is H2, right? Because they're both the same element. O2 is essentially an oxygen combined with an oxygen, and H2 is a hydrogen combined with hydrogen. Right? So these are both nonmetals, which means they're going to form a covalent bond, and that means they're sharing electrons. So this little diagram here has the yellow oxygen and the green oxygen, right? Let's talk about oxygen. How many valence electrons does oxygen have naturally? When it's just hanging out, when it's all by itself, how many does it have? 6. Okay? It's in group 16, which has 6 valence electrons. What's the magic number that oxygen's trying to get to? 8. So how many does it need to gain to be happy? 2. So, in a covalent bond or a molecular bond where they're sharing electrons, actually exchanging them, they're sharing. So the yellow oxygen in this picture is sharing 2 of its yellow electrons with the green. The green started out with 6. What's 6 plus the 2 yellows?
8.
8. Okay, so the green one's happy. But the green one is also sharing 2 of its electrons with the yellow oxygen.
So he's happy.
So they also have 8 by sharing. Okay, so it's kind of like if Wes and I both needed this piece of paper, right? And I got 2 hands on it, and Wes has 2 hands on it. Okay, we're sharing. It's really torn. So we both have the paper. While we both have the paper, it's neither fully mine and it's neither fully his, but it exists and we're sharing it, so we could say that we each have the paper. Does that make sense?
Yeah.
That's what's going on with us.
Okay, what about when you have the
They're
triatomic?
sharing. Oh, that's such an excellent question, Yash. When you have a triatomic, the same thing is happening, except electrons are being shared 3 ways.
But
Okay? They're being shared 3 ways.
now it has
Typically what happens here is these are what we call a double bond. So this is like sharing a pair of electrons, sharing a pair of electrons, and this one is also sharing a pair of
but now
electrons.
it's just mass chance. Yeah, they balance electrons.
Yeah, 2, 4, 6, 8.
Yeah, it's kind of.
Okay, so a triatomic molecule, 3 atoms that are exactly the same. Okay, again, I need you to focus. Okay. You can turn your body away from stack. There we go. Okay, so here comes the fun part. You gotta figure out how to name these things. This is really easy. It's really fun. And look, something beautiful. Okay, so the prefix 5. What number does that associate with? 2, like a bicycle. 2, okay? And molecular metals, non-metals?
Metal.
Non-metals. 2 non-metals in a compound. Okay? A binary molecular compound is 2 non-metals in a compound. So like hydrogen and oxygen. Okay? Alright, so when we name binary compounds, we use prefixes to tell us how many of each atom are there. Okay? Prefixes. So we have a specific list of prefixes that we're going to go over. Right? But when we name the binary molecular compound, the prefixes tell us how many of each atom is in the formula. So this first example that we have here, we've all seen it a gazillion times. Okay? CO2. Right? You get CO2. So how many carbons are present
1.
in CO2? Just 1. Remember, if it doesn't have a subscript, that little number to the low left, we can assume that there's only 1. How many oxygens are there?
2.
2. So when we name this thing, we have to have a way to indicate that number that's there. So what we do for the first element, if there's only 1, we just say its name. Carbon. Right there. But we have to use a prefix to tell that that there are 2 oxygens. So we use the prefix di, and then we use the first part of oxygen's name, which is ox. Okay, for the second element, you're going to drop the suffix. So in this case, we would drop gen, and we would add IDE. Okay, for binary molecular compounds, we always add on IDE at the end.
Where did we get the dye from? Yeah.
From that little 2 that's right there. Okay? So this, I know, I'm going to show you the zeros, so they're all a little different. Okay, so this one here. This element is nitrogen. How many are there? 2. So this is dinitrogen. And then how many oxygens are here?
4.
4. What do you suppose the prefix is for 4?
TTT. Tetro.
It's tetra. Anybody played the old school video game Tetris?
Yes.
You can move that shape 4 ways. Well, most of them, okay? 4 times is tetra, okay? So, tetra, and this is oxygen. So remember, when it's the second element, we take off the suffix, Okay, and we add in IDE. So this becomes dinitrogen tetroxide. There's dinitrogen tetroxide. Nitrogen tetroxide.
We only add the
Alright, so we need to put in our prefixes here. Some of them are filled in for you. If there's just one of something, that prefix is mono. Okay, mono.
So, will you ever need to put a prefix on the first element?
Not if there's only one.
But then why does mono?
Because what if we had, that's a really good question. What if we had this compound? Okay, how many carbons are there?
Carbon.
One, so we would just call that carbon, because we don't use mono for the first element. And then how many oxygens are there?
Monoxide.
Ha. Mon, we don't do OO, okay, so it's mon, ox, we drop the gen and add IDE. Okay, that was an excellent question. Alright, so after mono we have two, which the prefix is di. What about for three? Tri. What about four? Tetra. What about five? Penta, like the pentagon. Penta is five. What about six? Hexa. Seven? Hepta. Octa. Nana.
Deca.
Nana. And deca.
Will we ever get past?
You have to know these and we won't go past that.
But is there past 10? Like, will you ever? Are there more things that exist? Oh, 11.
Yes, except for these typically, yeah, there are. That's crazy, but we don't ever name those. We won't compare. Okay, good question. Josh, you're full of good questions. Alright, so let's practice this real quick. Let's practice this real quick. The first one that we have on our example says phosphorus tribromide. Okay, phosphorus tribromide. So what element, or what is the symbol for phosphorus?
pH.
It's a capital P. And how many phosphoruses are there?
One.
There's just one. So we don't have to write any subscript in there. Okay, so the next thing is tribromide. So what does tri tell us? There's three. And right. Bromine is going to be the bromide, and we'll give it a 3. So that's phosphorus tribromide. Phosphorus tribromide. What about this next one? What's this element here? Iodine. How many are there?
One.
Just one, so I don't have to use mono, so I just write in iodine.
Trichloride.
I love trichloride. Iodine trichloride. Alright. What do we got going on in the next one?
Pentoxide.
Okay, what's before that?
Diphosphorus.
Di, 2. There's 2 there. The capital P represents the element phosphorus. And the 5 tells us pent. Now, penta is the actual prefix for 5, but since we're adding penta to oxygen, we don't put A and O together. So we drop the A, and we put ox. And what else are we going to drop? We're going to drop the gen and add the I. So we get diphosphorus pentoxide. So now let's flip it in, okay? Now we're given the name and we have to write out the formula. So how's this going to start here? And yours is a little different than mine, okay? Yours, ours are opposite. Okay, mine has the word, yours has the symbol. But what's the symbol for sulfur? Capital S. And how many sulfurs are there? Just one. Alright? What's the symbol for fluoride? Capital F. And how many are there? 6. hexafluoride. What's that?
On that bottom one, I thought you're not supposed to do like 2 A's.
I know. I'm not
Typo.
good at English. I don't know how this works. Tetraarsenic.
Tetrarsenic.
Arsenic. Let's just pretend that the English is perfect. What's the symbol for arsenic? It's actually not AR, that's the symbol for argon.
Oh, it's AS.
AS?
So, AS.
How many AS's? 4, good?
And then O6.
Good.
Yeah,
Boom.
we got one more little piece.
Alright, we got one more little piece. Then we're going to do part of page 6, and then I'm going to turn you loose. Okay, so fortunately for you guys, you don't have to learn about naming acids. And that's good because they're kind of hard. But you do have to recognize these 5. Okay? So the first one is called hydrochloric acid. That is stomach acid. Okay? That's a naturally occurring acid in your body. And as long as it stays in your stomach, it's safe. Right? But once it starts leaving your stomach and going other places, then it gets bad.
What happened?
If the acid gets too far up in the bottom part of your stomach, hydrochloric acid, if it happens to get too far up in the top of your stomach, like if you suffer from acid reflux, it can eat away like holes in your stomach lining up top, and those can cause ulcers, which is very painful. If you have a problem and you vomit all the time, that stomach acid can corrode the inside of your esophagus and cause lots of problems there. Okay, so it's good where it's supposed to be at the bottom of your stomach, but if it gets other places, it's bad. Alright. It is liquid. Acids are liquid. They all have hydrogen at the front. Okay? When these are in solution, they're acids. Okay? Alright, so what element is this right here? Penny?
That's sulfur.
Sulfur and then oxygen.
Okay, so this is sulfur and acid. This is called sulfuric acid. Sulfuric acid.
Isn't that what's in like acne stuff?
I don't know. You might be right. Like in proactive? No, that's salicylic acid. Different. Yeah. Don't put sulfuric acid on your face. What element is this?
Nitrogen.
Nitrogen. This is nitric acid. Stop. You two are wearing this one's kind of freaky. This is the acetate ion right here. This is called acetic acid, and that's the same thing as vinegar. Every time I smell vinegar, I think of Easter eggs dying. Not Easter eggs dying, like actually dying.
Oh.
What element is this key? Phosphorus, which is phosphoric acid.
That's more.
Yes, sir.
My brother says there's acid in your pee. Is that true?
Uric acid, yes, sir.
It's okay to drink them.
No,
They can melt walls.
My dog.
If you boil it, it's okay. No, you can drink your own pee.
the reason why your body is getting rid of it is because it doesn't need it. So consuming it is horrible.
Yeah.
It's a rival situation.
Is it really?
I hate beer girls. I'll talk about it later.
I want to
They're
know.
I like the other guy though.
Okay, this is the last thing that we're doing. Okay, then I'm going to turn you loose to do your homework. This is page 6 in your pack. It's the thinking map. Okay? We are doing the right side. Are you with me? Yes, the covalent side. The first thing I want you to write down is molecular up there next to covalent because they're one and the same. Molecular. So, this is going to be 2 nonmetals, right? So, an example of 2 nonmetals bonded covalently would be okay? How would we name this?
Hydrogen monoiodine.
Hydrogen What about this one?
Nitrogen,
No, dinitrogen.
dinitrogen.
Trioxide.
Come on, Josh.
Dinitrogen trioxide. So the rule, okay, this on your paper is actually underneath here, like that, okay? But the rule, if we use prefixes to tell the amount of each element. Use prefixes to tell the amount of each element. And on this line here, we're going to write the mono exception. Okay, the mono exception is that a prefix is not needed on the first element if there's only one. Okay, so we don't use mono on the first element, which is why we did not write monohydrate monohydrate. So let's go through our prefixes really quick. One is mono. Two is di. Three is tri. Four. Tri. Five. I'm going to play this video for your mother when I explain to her what I'm teaching them in class. Six is hexa. Hexa. Good. And deca. Excellent. Excellent. Okay, last little part. For acids, which element do they contain at the beginning of the formula? Hydrogen. Hydrogen. And what is this one called again? The stomach acid one.
Hydrochloric.
Hydrochloric.
Sulfuric. Nitric.
Sulfuric.
Acidic.
Nitric acid. Acetic acid, which is also vinegar.
I don't remember the last one.
Phosphoric.
I said try.
Phosphoric acid.